this is Saritha, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering. Today's session I am going to explain about smoothing of spatial filters. So what is mean by filter? With the use of filter, we can remove the noise components. In that filter, what is neighborhood operations? Neighborhood operations means we need to consider this is entire image. So here this is origin, we are representing this image f of x comma y. Here in this f of x comma y, consider this is the sub image. This part is sub image. So sub image, this is location we are representing with f of x comma y. So here neighborhood is defined as any area bigger than the single pixel, Here this is single pixel. If we are considering here the size of the image is bigger than the single pixel. Here the size of the image here, this is sub image. Here the size of this sub image is 3 by 3. The size of the sub image is 3 by 3. Here maybe the size or shape. Here the image it is in 3 by 3. So when we go for 5 by 5 means we need to consider 5 rows and 5 columns, means it consisting of total 25 pixels. And here in this the size of the image. So the size of the sub image, for example, sub image is nothing but entire this image. We are considering only 3 by 3, 9 pixels. So here it is 3 by 3, or we are considering 25 pixels, that is 5 by 5. Then in this neighborhood operation, when we go for filters in spatial filter operation, we are applying the filter. Mask onto the sub image. So if sub image size is 3 by 3, at that time we need to superimpose we can apply the filter mask. Each and every pixel of the sub image we need to apply the filter mask. So if sub image size is 3 by 3, then our filter mask size is also 3 by 3. Here point or neighborhood processing. So point processing, a pixel gray level is changed without acknowledge of its surroundings. Pixel means if we are considering one image, in that the point is nothing but here it is pixel. So without acknowledging of its surrounding pixels. But when we go for neighborhood operation, if we are considering the sub image, in that sub image, this is for example the center pixel. So we need to consider the neighboring pixels also. This neighborhood pixels also. Here neighborhood processing to change a gray level of a given pixel, we need only know the value of the gray levels in a small neighborhood of pixel around the given pixel. Here, local or neighborhood operation. So in this neighborhood operation, the pixels in an image are modified based on some function of the pixels in the neighborhood. So here linear spatial filter is referred to a convolution convolving mask. So we are applying, if we are considering sub image, we are applying filter mask onto that sub image. So multiplying those pixel values, sub image mask and sub image, we are applying the filter mask. Then multiplying those pixel values is nothing but convolving mask. Sometimes the filter masks are sometimes called convolution mask or convolution kernels. So observe here in this image, this is entire image. We are representing here it is f of x comma y. In this f of x comma y, here this is mask. So mask we are representing here. If we are considering sub image is 3 by 3, for example here it is sub image. We are representing Z1, Z2, Z3, Z4, Z5, Z6, Z7, Z8, Z9. This is sub-image. So we are applying the mask, filter mask. We are applying the filter mask. Here that filter mask we are representing W1, W2, W3, 4, 5, 6, 7, 8, 9. Here output filter. Here output filter is nothing but Z1. This is filter mask. Filter mask. This filter mask apply onto the sub image. Each and every each and every pixel of the filter mask superimpose on this sub image. Then what will happen? That output Z1 into W1 plus Z2 into W2 plus Z3 into W3 plus Z4 into W4 plus Z5 into W5 plus Z6 into W6 plus Z7 into W8 plus W7 Z8 into W8 plus Z9 into W9. Here this is the filter. Whatever the resultant here, whatever the center pixel here, it is Z5. Whatever the filter output, so that filter output, so whatever the resultant, that resultant reflected on our Z5 location. Resultant reflected in Z5 location. So this is the mechanism of spatial filtering. This is the mechanism of spatial filtering. For example, consider here 4:5 image. 4:5 image. In this 4:5 image, here I1, I2, I3, I4, I5, I6, I7, I8, I9, I10, I11, 12, 13, 14, 15, I16, I17, I18, I19, I20. So this is my center pixel. For example, here I4 is, for example, center pixel. So if I am applying submask, the size of the submask is W1, W2, W3, 4, 5, W6, W7, W8, W9 here. So this image this submask, so place in the sub image here. I4 is the center pixel. Then whatever the size of the image here these pixels are 0, 0, 0. What about here the sub image here 0, 0, 0, I3, I4, I5, I8, I9, I10. So this is sub image and this one is filter mask. Then what about our output? Output of filter? Filter is 0 into W1 plus 0 into W2 plus 0 into W3 plus 0 into W4 plus 0 into W5 plus 0 into W6 plus 0 into W7. Sorry. Here I3 into W4 I3 into W4 plus I4 into W5 plus I5 into W6 plus I7 into W7 plus I8 into W9 plus here I8 into W7, here I3 into W4, I4 into W5, I5 into W6, I8 into W7, I9 into W8, I10 into W9. Here, whatever the resultant is there, that resultant is reflected in our I4 location. For example, here, I need the value of this I6. So, what about the sub image here? These values are 0, 0, 0. Here, the sub image is I0, I1, I2, 0, I6, I7, 0, I11, I12, I12. Here, this is the sub image. So, sub image. So, we are applying the filter mask here. W1, W2, W3, W4, W5, W6, 7, 8, 9. So, whatever the resultant here, 0 in here 0 into W1, I1 into W2, I2 into W3, 0 into W4, I6 into W5, I7 into W6, 0 into W7, I11 into W8, I12 into W9. So the resultant, whatever the resultant is there, that resultant is reflected in our I6 pixel. So this is the mechanism for spatial filtering. So in this, for example, 5 by 5, consider 5 by 5. 5 by 5 image. So 5 by 5 image means here Z1, Z2, Z3, Z4, Z5, Z6, Z7, Z8, Z9, Z10, Z11, Z12, Z13, Z14, Z15, Z16, Z17, Z18, Z19, Z20, Z21, Z22, Z23, Z24, Z25. Here, this is my image. This is my image. So, apply the filter mask. So, apply the filter mask. So, that filter mask here, W1, W2, W3, W4, W5 here, 6, 7, 8, 9, 10. So here W11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Here 21, 22, 23, 24, 25. So this is my filter mask. So what about our filter output? What about our filter output? Filter output is Z1 into W1 plus Z2 into W2 plus Z3 into W3 plus Z4 into W4 plus Z5 into W5 plus Z6 into W6 plus Z7 into W7 plus Z8 into W8 plus Z9 into W9, Z10 into W10, Z11 into W11, Z12 into W12, Z13 into W13, Z14 into W14, Z15 into W15, Z16 into W16, plus Z17 into W17. Here Z18 into W18. Z19 into W19. Z20 into W20 plus 21 into W21 plus Z22 into W22, Z23 into W23 plus Z24 into W24 plus Z25 into W25. So here, whatever the resultant is there, that resultant is reflected in our Z13. So this is the center pixel. This is the center pixel of this image. So this is the filter mask. Here, with the use of this filter mask, we can remove the noise components in our image. So here the image, depending on sub-image size, if the sub-image is 3 by 3, we are using the filter mask size is also 3 by 3. If it is 5 by 5, we can use a 5 by 5 mask. So based on that, we can remove the noise in our image. And next one is mean filter or averaging filter or low pass filter. So here mean filter or average filter or low pass filter. So the mean filter replaces each pixel by the average of all the values in the local neighborhood. Here average of pixels. So here average of pixels. Here the size of the image, either it is 3 by 3 or 5 by 5. The size of the neighborhood controls amount of filtering. So in spatial averaging operation, each pixel is replaced by weighted average of its neighborhood pixel. So in this mean filter or average, here the low pass filter preserve with the use of low pass filter. This mean filter is also called as low pass filter. With the use of this low pass filter, smooth the region in the image. So it removes the sharp variations leading to the blurring effect. So with the use of low pass filter, it's smoothing the image, and when we go for high pass filter, it's sharpening of an edges. So here 3 by 3 spatial mask which can perform the averaging operation. Averaging operation is given below here. So here what are the limitations of averaging filters are given. Here the averaging operation leads to the blurring of an image. So blurring effects features localization. So how we can remove these blurring effects? In this blurring, we are having some salt noise, pepper noise. Those noises we can remove with the use of median filter. So in this average filters, we are having blurring the effects feature localization. If the averaging operation is applied to an image corrupted by impulse noise, the impulse noise is attenuated and diffused but not removed. So we can reduce the noise components, but it is unable to remove those noises. So with the use of this average operation, the size of the mask is increased. So the size of the mask is increased, then image gets blurred. Here, for example, read image. So involve the image with mask. Here 1 by 9. 1 by 9, here average mask is 111, 111. So here the total number of pixels. What is the value here? 9. So 1 by 9. So averaging of all the pixel values, here the total value is here 9 only. Then we are representing here 1 by 9 into 1, 1, 1, 1, 1, 1, 1, 1, 1. For example, here 1 by 25. 1 by 25 means here 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Here 1, 1, 1, 1, 1, 1, 1, 1, 1. Here the total value of these all pixels are 25. 1 by 25 into this one. Here here the image size is 3 by 3. Here the size is 5 by 5. Here whatever the values, here if we are using 3 by 3 image, in that depending on pixel values, add those pixel values. So here average filter means 1 by the total values into that image. So here perform the average operation which results in blurring of the image. Here to analyze the impact of increasing the size of the mask to 5 by 5. Here the mask is, here it is 3 by 3. We can increase the mask size. We can increase the mask size from 3 by 3 to 5 by 5. Here the pixels are 1 by 25 into 111, 1111111. So here the total adding of these all pixel values, here it is 25. So MATLAB code for this averaging filter, here from the result. So after completion of that code, the size of the mask is increases, the blurring is also increased. The blurring is also increased. Also, one can observe that a spatial filter is implemented through convolution, the mask H1 and H2. So generally called a box filter. So what is the code? Here CLC, clear all, close all. Here A. Here A equals to image is rose image. Here 1 by 9 is the image size is 3 by 3. Here 1 by 25 means the image size is 5 by 5. Here convolution, here A1. So first image convoluted with H1 and image A convoluted with H2. Here H1, H2 means we are using the image sizes are here H1 is 1 by 9. Here H2 is the 1 by 25. So the title of the image, first image is original image and next two images are nothing but 3 by 3. We are applying the mask size is 3 by 3 and next we are applying the mask size is 5 by 5. Here we are applying the mask size is 3 by 3, that is we are representing with H1, then A1 comma H1, then the mask size here it is 5 by 5, that is we are representing A comma H2. Here the images, here the first image it is original image and next two images are first one is 3 by 3 mask and next one is 5 by 5 mask. Here first original image, when we are applying the mask size is 3 by 3, here this image gets somewhat blurred. So again we are increasing the mask size. Mask size increases from 3 by 3 to 5 by 5. It gets blurred. So it is compared to 3 by 3, it is more blurred. So when we go for this effect of average filter for salt and pepper noise, this is our original image. So this is salt and pepper noise. Here we are applying the average filter with the mask of 3 by 3. In this image is not clear, it blurred image, and with the salt and pepper noise is affected with salt and pepper noise. Here also image is blurred, it is not clear, it is also suffered with the salt and pepper noise. So how we can remove this salt and pepper noise? How we can remove this salt and pepper noise means with the use of median filter. With the use of median filter, we can remove the salt and pepper noise. So how we can use that median filter? How we can remove the salt and how we can reduce the salt and pepper noises? I will explain you. So here, effect of averaging filter for Gaussian noise. This is Gaussian noise here. In this we are using 3 by 3 averaging filter. Here it is 5 by 5 averaging filter. In 3 by 3 averaging filter, image is also blurred with Gaussian noise. In 5 by 5 averaging filter, image is also blurred with Gaussian noise. And when we go for order statistic filters or non-linear spatial filters, whose response is based on ordering. whose response is based on ordering the pixels contained in the image area. The pixels contained in the image area here encompassed by the filter, here median filter. With the use of median filter, we can remove the salt and pepper noise, and maximum filter. With the use of maximum filter, finding the brightest point in an image, and minimum filter opposite of that maximum filter. In the minimum filter, it find out the dark point in our image. So consider one example. In this example, 10, 20, 20, 20, 15, 20, 20, 25, 100. So for this case, how to find the median value, maximum filter output and minimum filter output. In this median filter output, for that case, first write all the values in our ascending order. Here 10, 20, here 10, 20, 20, 20, 15, 20, 20, 25, 100. Here the gray levels are like this. Then write in the ascending order 10, 15, 10, 15, 20, 20, 20, 20, 20, 25, 100. So in this median filter, what is the middle value here? So middle value is 20 only. So 20 only. Here the median filter output is 20. If the number, here in this case we are having total 9 numbers. So we are getting value is 20. Here if we are having 2 numbers in middle, means average of 2 numbers. If it is greater, rounding the value. Here maximum filter output. Maximum filter output means, in the name indicates, if you are considering any one image with the use of maximum filter, it finding the brightest point. Means if the gray level is maximum. So if you are considering any one image, brightest point means that pixel is consist of gray level value is high compared to neighboring pixels. So that is nothing but maximum filter output. Minimum filter output means if you are considering any one image, in that which pixel is dark, that pixel has lowest gray level value compared to neighborhood pixels. So here in this case, what is the minimum value? 10. And what is the maximum value? It is 100. So median filter output is 20. Maximum filter output means what is the maximum gray level value? That is 100. And minimum gray level value is 10. So this is the median filter, maximum filter and minimum filter. So consider one more example. For example, consider one image. 1, 4, 7, 5, 2, 1, 3, 4, 2. So in this image we are having 1, 4, 7, 5, 2, 1, 3, 4, 2. So these values write in ascending order here 1, 1, 2, 2, 3, 4, 4, 5, 7. 4, 5, 7. So in this, maximum filter output is 7, minimum filter output is 1. What about middle value? 1, 7, 1, 2, 4. 1, 1, 2, 2, 3, 4, 4. Here 1, 7, 1, 5, 2, 4, 2, 4. Here middle value is 3. So here in this case, median filter output is 3 and maximum filter output is 7 and minimum filter output is 1. And here in this median filter or statistical non-linear filters that are often described in the spatial domain. A median filter smoothen the image by utilizing the median of the neighborhood. So in this median filters, so how to find the median filter values? Here all the pixels, all the pixels in our image, so neighborhood of the pixels in the original image which are identified by the mask sorted in the ascending or descending order, the median of the sorted value is computed and chosen as the pixel value of for the processing image. So whatever the in that image, first if any image is there, so first write all the values. So first write all the values. Depending on that, how to find the median values means if you are having 5 by the image size is 5 by 5 means in this we are having 25 pixels. But my submask is sorry, if our filter mask the size is 3 by 3, so at that time we need to consider out of this 5 by 5 we need to consider only 3 by 3 sub image only. 3 by 3 is the size of the sub image. So we are applying the filter mask is also 3 by 3 here in the first point. All pixels in the neighborhood of the pixel in the original image which are identified by the mask sorted in the ascending or descending order. So the median of the sorted value is computed. So first to find out the image size, and after but all the values write in ascending order. In that order find the middle value. So that value replaced with our center pixel. Here consider one image. Here this is my sub image. So in this example, compute the median value of the marked pixel. Here the image size is 3 by 3 only. 157246321. So out of this, here it is, this is my center pixel. So I want to replace this with the median value. Here first in our image we are having 157246321. 3, 2, 1. Here, first write in ascending order. 1, 1, 2, 2, 3, 4, 5, 6. Here, what is the? Here, 4 is replaced with 3. 4 is replaced with 3. So, what about our resultant image? Our resultant image is 1, 5, 7, 2, 3, 6, 3, 2, 1. Here our original image is 1, 5, 7, 2, 4, 6, 3, 2, 1. 3, 2, 1. So, like this, here this is the median filter. So, in this median filter, consider one more example here. 1, 5, 7, 4, for example. 5 by 5 mask consider here. 3, 2, 1, 3, 4, 1. 1, 2, 3, 4, 2. 1, 7, 6, 5, 4 here. 1, 3, 4, 5, 6. This is my image. This is my image. So I need to change these 3 pixels. So at that time our my submask size filter mask is 3 by 3 only. Filter mask is 3 by 3 only. So here our image is, so here one is 1, 5, 7, 2, 1, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3. Here, this is my center pixel. First write all the pixels. 1, 1, 1, write in ascending order. 2, 2, 3, 3, 5, 7. 3, 3, 5, 7. Here 1, 1, 5, 1, 3, 2, 2. So this 1 replaced with, completed with 2. So this is the median filter. So when we go for, this is my center pixel. So we need to use this one. So this is my center pixel, means here the image size is this one. So with the use of this median filter, we can remove the salt and pepper noises. So how we can remove salt and pepper noises means, with some example I will explain you in a next session. So in this with the use of here, depending on mask size, if whatever the image size, that image size either it is 10 by 10 or 5 by 5, depending on filter mask. In this image it is 5 by 5 only, but my filter mask size is 3 by 3 only. So for that case I am considering only here the sub image is 3 by 3 only. Here also 3 by 3. So I need to consider this one. For example, if it is 5 is my center pixel, then mask size is 3 by 3 only. So I need to consider this one. Here mask size is 3 by 3. Center pixel is 7 inch. Need to consider this one. For example, it is 6. Then we are considering this one. So based on this, find the median value. So this is the one example. In this example, how to find the how to find the values means, for 128 we need to consider this level, for 24 need to consider this level, and 172 need to consider this level. So consider these levels and how to replace. Here the gray level value of 128 compared to these neighborhood pixels, large variation is there. Here 172 also is large variation is there. So based on median filters, how we can replace this 128 gray level, how we can replace with some other value, and how we can remove the salt and pepper noises. So in this session, explain the order statistic filters. In this order statistic filters, we are having median filter, minimum filter, and maximum filters, and mechanism of spatial filter. So in that mechanism of spatial filters, how we can with the use of spatial mechanism of spatial filters, first consider the sub image and how we can apply the filter mask on that sub image. So here multiply the sub image into filter mask, then whatever the filter output is there, that resultant stored in our center pixel. So for example, if you are considering in a 3 by 3 mask, the center pixel in our sub image, the center pixel is 5. Whatever the resultant is there, the resultant is stored in center pixel. And how we can remove the salt and pepper noises with the use of median filter, I will explain with some example. Continue in next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.